give me the group homework number 1 today. It's due, it says due on Wednesday. We're going over it, okay? How many of you finished it? Okay. We're going over it, you know, you have to kind of doing what? Hydrocarbons. Now, we mainly talked about open chain saturated hydrocarbons, the straight chain hydrocarbons. They are also called alicyclic saturated hydrocarbons. All right, today we're going to look at more details of alkanes. Then we will move on to other types of alkanes, cyclic alkanes, cycloalkanes, and unsaturated. I want you to understand this. This is pentane, and this is isopentane, a branched alkane, and this one is another isomer of pentane. In here, there's a quaternary carbon atom. What do you mean by quaternary carbon atom? The carbon atom attached to 4 other carbon atoms, right? In the middle, there's a carbon atom, and then there are 4 other carbon atoms. Tertiary means this one has tertiary carbon atom. This one is primary, 2 primaries. In a linear structure, 2 primary carbon atoms at the end, and the middle ones are secondary carbon atoms, right? Now, if you look at this, they all have the formula C2H12. Therefore, these are isomers. Specifically, they are constitutional isomers. They have different properties. If you look at this, pentane boils at 36.1 Celsius. Isopentane boils at 27.8. And neopentane. Neopentane is the one with the carbon atom, tertiary carbon atom in the center, and it boils at 9.5 Celsius. Now, what is the trend here? As the branching increase in a particular alkane, boiling points decreases. The reason for that is when the things get branched off, in the liquid state or the solid state, they cannot pack properly. They don't pack nicely. There are things coming out. This linear molecule will feed in the liquid or the solid in a flat way on top of each other nicely, and they will be attracted firmly to each other. Therefore, to make them move away, that means become a liquid or a gas, would require higher energy here. Higher energy means higher temperature. That means 36.1 for the straight chain alkane. And because they fit less as the branching take place, the boiling point increase, right? So you got the idea that in an alkane, the isomers, constitutional isomers that are more branched, have lower boiling point. That means they boil off easily, right? Easier than the straight chain. I'm gonna look at the constitutional isomers. For example, in the earlier problem, we had 5 carbon atoms. So these 3 were the only, the pentane, isopentane, and neopentane were the only possible constitutional isomers. Now there's a list of, this table gives alkane with 1 carbon atom, there's only 1 isomer. Up to about 3 carbon atoms, all right? There's not going to be any constitutional isomers because there's no branching up to propane. You cannot stick another carbon atom somewhere different from what is already there. So after about carbon-3, there's no constitutional isomers. But when you get to the butane, we talked about that. Butane has butane, normal butane, and isobutane. Remember? We talked about isobutane with tertiary carbon atom, right? Tertiary carbon atom from the other class. Okay. And pentane has 3, as shown previously. And when you get to the 6, there are 5. Okay. Now you should be able to really get down and write down these things and prove yourself. You know, there's only 5. You can superimpose them, and if you draw a different isomer, if they can be superimposed, that means the same thing, right? Sometimes on the paper they may look like different, okay, but in reality it's the same thing, right? For example, pentane have 5 carbon atoms. 1, 2, 3, 4, 5. Okay, there's a 1 isomer here. Then you take out a 1 carbon atom here, right? Okay, 1, 2, 3, 4, 5. That's one of them. That's the. This is going to be isopentane, like that. Okay, number 3. How about this? Is it different from this one? When you turn the isopentane molecule around, it's not going to be different, right? It's the same thing. I mean, the molecule, you can turn it around and superimpose, right? This is the line angle formula. Okay. So therefore, you understand that there are going to be different isomers when the carbon number changes. 5. If it is 6, I wrote down 3. We'll write down. I only want you to remember these numbers: 3, 5, 9, 9, 3. 5 is 3. 6 is 5. 5 is 3. 7 is 9. 8 is 18. Okay. Up to about this. Okay. Up to about 8. You should know. Okay. All right. There's a question later that we ask how many isomers are possible. If you remember the one that we done before, okay? The question is, give the number of constitutional isomers possible in the following alkane. What would be the C4? CH4, 1 carbon atom alkane, there's only 1. Okay, this is going to be only 1. There's going to be only 1. And C4 going to be 2. This is going to be 3, 5. This is going to be 9 and 18. So what was the 35? Okay. All right. Now at least you have to understand that basically why CH4, methane, ethane, and propane don't have isomers, right? Then it starts with butane because you can branch the alkane chain, right? Start with carbon number 4. Okay, we got that part now. All right, I'm going to do this question, the second question on group homework 2. Now the question is, give the IPAC name of the following branch alkane. Okay. Now the condensed formula is given, right? Condensed formula is given. Now branch alkyl. First you have to get the expanded formula. What is expanded condensed formula? It is like this. CH3, you show carbon-carbon bonds. It's not expanded structural formula. It's expanded only in terms of this is CH3, second carbon atom attached to two CH3 groups, and that's going to be CH2, CH, okay? Now this group is attached to CH2, CH3, just little space limitation here, then that one is CH2 and CH3. What I did was expanded the carbon-carbon bonds, right? Now we are asking you to do the line angle formula, okay? Okay, if you look at this, how many carbon atoms are here? You can say 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. Right? Okay. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Do you understand that there are 3 lines coming up here? Why is that? That's for the CH3 groups. All right? And then here, this should be like this. Why is that? This carbon atom, I'm going to label it 1, 2, 3, 4, 5, 6. I should add that. Okay. 1, 2, 3, 4, 5, 6. Okay. Now I'm using IPAC naming, all right? In the IPAC naming, first thing is to find the longest chain, right? Then give the lowest number to the first branch. So, okay, let me do it this way. First branch, this is complex too. I mean, 1, 2, 3, 4, 5, 6. Lowest number to the first branch. If you go this way, to the left, then you get this one a higher number. So give the branch the lowest number. Okay. Now, therefore, this is the line angle formula. I use this information to draw the straight chain. This is going to be a 6-mean hexane, right? Parent chain is going to be a hexane. Okay. Now branch alkyl groups. Okay. In here, there are methyl groups. How many methyl groups? Let me. 2 or 3? 2. Because you don't count the methyl group on the parent chain. Okay. This is supposed to be the parent chain. Therefore, dimethyl. Right? All right. This group is ethyl. Right? So now we put the numbers on here. This will be 2 dimethyl, right? And that is going to be that's going to be 4 ethyl, right? So this way there are 2 groups, 3 alkyl groups branching of this. Therefore, what would be the IPAC name now? 2 dimethyl. I think 4 ethyl hexane. Got it? All right. We got that naming of a branch alkane and all the various forms of formula here. Right. Okay, let's do this one. Okay. Identify the types of carbon atoms in the following structure. Types of carbon atoms. The only thing we talked about types of carbon atom is primary, secondary, remember, tertiary. Okay. So there are a lot of carbon. Okay. Start with this. I would say this one is primary because it's attached to another carbon atom. Right? The corner carbon atom is attached to another carbon. And this one is going to be what? Quaternary. Why is that quaternary? It's attached to 4 carbon atoms. Did you see in the 4 carbon atoms? I mean, if I put that one, there's another carbon atom, right? So, okay, this one is going to be primary. This one is going to be primary carbon atom. What is this one? Secondary. Anyone, everybody clear about that? Okay. And this one is tertiary because they are that, and this is going to be secondary, and this one is the primary, and this one is going to be secondary, and this one will be primary. Okay. Now the hydrogen atoms attached to this carbon have types going to be primary hydrogens, secondary hydrogens. All right. Quaternary carbon atom cannot have any hydrogen. You understand that? For example, the question will be how many secondary carbon atoms are in this structure? What would be the answer? We have to put 3 secondary carbon atoms. How many primary carbon atoms are in this? Okay, there's only 1 quaternary carbon atom. Okay, maybe this is the question that I missed last time. In the group homework 1, you already have a group homework 1, right? Already finished. What I did was, I will show you why my confusion was. In this case, I created a rule for that myself. Most common that we're going to read it later, right? So rule was not clear. Pick the longest chain. That would be the parent carbon atom. Then number alkyl group to give lowest number. That was what was written down. Then here I had 2 alkyl groups, 2 carbon atoms, which is a complex one and a smaller one here, the simple one. You see this one here, and this one. I assume this should be given the priority. But the rule is the first branch should get the lowest number, first branch. Okay? So when you're doing this for cycloalkane, that's where I got confused. It's a different issue. I think I got that from confusion from that. Therefore, this should be labeled like this. Okay, I made a mistake. I said heptane. It should have been heptane, right? Parent chain is heptane. And that methyl group's going to be 5, 5, 2, 5, 5, trimethyl. It should be heptane. Can you correct in your answer sheet? Okay. Okay, what is the rule now? The first branch, the at least lowest number should be given to the first branch. Like if this branch was taken as then it will be 3, right? Therefore, we take this as the first branch, right? This hardly come into play. This was a kind of a complex molecule, right? Most of the structures we ask you to name are much simpler. 2, 5, 5 trimethyl heptane, right? Okay. Now the We wanted to understand chemical properties of alkanes and cycloalkanes, right? What kind of a reaction they undergo. First one is combustion reaction, combustion of hydrocarbons. Okay, combustion is generally assumed as a reaction of oxygen with a hydrocarbon or organic compound to produce carbon dioxide and water, combustion, right? So the energy is produced. That's where we use that energy to heat water or also to create electricity. We boil off water, then generate the steam, right? Then steam engines will drive a electrical motor, right? Then produce the electricity. So there are a lot of natural gas burning power plants, but we have coal burning power plants. Coal is carbon plus oxygen, carbon dioxide, water. No water, carbon dioxide for coal, and nuclear energy is another one. In a nuclear energy could also be used to heat the water, right? Energy coming up. So what are the products? Carbon dioxide and water. So amount of carbon dioxide and water is going to depend on the number of carbon atoms. You have to balance the equation. That's one reaction. We will be balancing few reactions later, okay? Another reaction is halogenation. Halogens are chlorine, bromine, iodines are called halogens. A reaction of alkane in the presence of light. This takes place to replace the hydrogen atoms on the alkane. Here we find the monosubstitute ethyl bromide here. Name of the compound is ethyl bromide. Ethyl bromide is the common name. Bromoethane is the IPAC name. Bromoethane, and hydrogen bromide is produced. Now, if you had more bromine, it will go on replacing the other hydrogens. Now, also you have to understand how this reaction is used in generating freon. What is freon? You heard about freon?
Goes in your air conditioner, doesn't it?
Right. Freon 1,1 and freon 1,2. Now is in the air conditioning. Now freons are called chlorofluorohydrocarbons, right? Chlorofluorohydrocarbons. CFCs, right? So to produce this, you produce that. If you have a chlorine here, you produce the chloromethane, ethane here, right? And then you react with fluorine, then you produce the fluoromethanes, ethanes, right? And you can produce a lot of freons. Okay, I'm going to talk about freons a little later. This is the reaction of alkanes. Now the same thing happened to cycloalkanes. We're going to talk about cycloalkanes. Where you have a ring, in the molecule. It's not a straight chain or branch chain, but it also has a ring. Okay, let's do this reaction. Okay, question is complete the combustion reaction of following alkane. Okay, combustion reaction is oxygen. All right, oxygen. All right. What is missing here is stoichiometric coefficients in front of the chemicals, and you put an arrow. It's a complete reaction here. One single arrow. Carbon dioxide. There should be you should know what is the stoichiometric coefficient in front of water and carbon dioxide and oxygen. Right. So if you complete this, you will have all the answers. Okay. How many of you done balancing chemical reactions in 120? Okay. All right, you go carbon 1, all right. Then you find out there are 3, okay, 3 oxygens. When the carbon number is even, what was this? Hydrogen has to be 4. Hydrogen has to be 2, right? There are 4. I had to balance carbon and hydrogen first. I just forgot about the hydrogen, right? Okay. Now you don't have a problem. The odd is the one problem. Okay. Now, I mean, I was trying to create the rule here. Which one has the problem? Okay, 2. Then this will be 2 also, right? And this would be 1, 1. So we don't write ones, right? In this case, I will leave it 1, okay? Now it is balanced, right? So that rule I said, don't apply to even numbers. Even numbers of carbon atom. Okay, this is senior moment, okay? Okay. Odd is okay. Even is a problem. Okay, all right? Now, you're not going to forget this one, right? Because I may making a fool of myself here. All right. I'm trying to explain things, sometimes I get carried away. You got it, right? Okay, this one. Yeah, let's go to the 4. And there's going to be 4 here. Oops. That's going to be 4 here. Why is going to be 5? 5 here. I cannot multiply to there. Okay, 5 there. Okay, now what is the problem here? 8 plus 5 is 13, right? 8 plus 5 is 13. Okay, I got that right. So 13 divided by 2, right? Okay, now E1 has a problem. What is the problem? Get the fractional oxygen, right? So therefore you had to multiply by the 2, and when you multiply by 2, this becomes 8, then this becomes 10. Got it? Okay, now this one don't have a problem. Why? It's odd. Now I got it even and odd. Correct. All right. All right. This is going to be 5. That's going to be 6. Right? And 10 plus is going to be 8. You say? Okay. Okay, now you guys are masters of balancing combustion reactions, right? No? Now, as I told you, haloalkanes, haloalkane is chloromethane, chloroethane, like that. Haloalkanes are the IUPAC names. Chloromethane. Chloromethane is carbon on the methane, one hydrogen is replaced by a chlorine atom, right? What would be the formula of chloromethane? CH3Cl, right? Now alkyl halide is the common word, right? Alkyl halide is methyl chloride, like a sodium chloride, it's kind of a common. And now we wanted to compare alkanes to halogenated alkanes to alkanes. Many halogen derivatives are higher than water. Anyway, many halogen derivatives are heavier than water. Now, normally alkanes are less heavier than water. Do you understand that? Oil, gasoline floats on the water, right? If you have oil spill, it will be on the top of the water. But if you have a test tube and if you put some water in it, if you have a test tube here, if you put halo alkane, now add water. Where would be the water going to be? Water will be on top of it. This is water. Why is that? It's heavier than water. They are polar compounds, all right? Alkanes are not polar. Therefore, sometimes if you want to dissolve some polar hydrophilic organic compound where they contain polar groups, carboxylic acid or ions, then we use chloroform. Chloroform is CHCl3, methylene chloride, CH2Cl2, like that. Boiling point are higher because the weight is higher, right? When you replace a hydrogen with a chlorine, the molecule is going to be heavier, right? Didn't I tell you about this when you try to distill alkanes in a refinery? You get first you get the lower boiling or the small hydrocarbon coming out on the top, right? Then they come first, then the as you increase the temperature, the heavy boiling ones comes out. The reason for that is the weight, molecular weight is going to be higher with the higher carbon number, right? We're going to talk about saturated and unsaturated hydrocarbons. Unsaturated hydrocarbons have double, triple bonds. Physical properties are similar to those of saturated hydrocarbons, but the chemical properties are different because there's a double bond here, which is reactive. Okay, we're going to talk about that. Chemically, saturated hydrocarbons are stable, but the unsaturated are reactive. Now there are three types of unsaturated hydrocarbons. First one is called the alkene. Ene now, not ane. The last name ene end with alkane, end with the ene means it's a double bond. At least one double bond is there, right? Ene means Y-N-E-S. Enes means contain one or more carbon-carbon double bond. Genes means Y-N-E-S. At least contain one carbon-carbon triple bond. Now we're going to talk about aromatic hydrocarbons. They're different. Let me show you one structure. Okay, here. They're different. How many aromatic hydrocarbons have how many double bonds? 3. But they're in a 6-membered carbon cycle, right? Alternating double bond. Okay, when you contain at least one of these or many of these in the molecule, the molecule is called aromatic hydrocarbon, right? Normally, alkenes and alkynes, they're related to alkenes. But they are not in a alternating double bonds here, alternating with single bond, double bond, alternating with single bonds here, right? They are aromatic, especially when they are in a 6-membered. Right? Now you understood some characteristics of unsaturated hydrocarbons now. Now let me cycloalkanes are in chapter 12. Cycloalkanes. Now, what is the difference here? This is line angle formula of cycloalkanes. Now, let me show you a diagram here. Now, this one has 5 carbon atoms, right? You can see that. Which one is this? This one is this, okay? This is the ball and stick model there. Now, how do you make a alkane, cycloalkane now from alkane? Okay, I want to show this. Okay, the counterpart in alkane is the pentane, linear pentane, normal pentane here. So to make a cycle, you have to get the ends, terminal carbon atoms, which are CH3 groups. Remove 2 hydrogens, right? Here. Up, the wrong one. Remove 2 hydrogens, all right, here. And connect these two, yes. So what did I do here? I took out 2 hydrogens, right? And I created the cycloanalog, cycloalkane, cyclopentane. When you have a ring, we call it cyclobutane, cyclopentane, cyclohexane, right? So they are similar to alkanes, but their formula, general formula for cycloalkane is not CnH2n plus 2, because we have less, 2 hydrogen less. Formula going to be CnH2n, all right? So if you are asked to do a cycloalkane, then what is the formula? Then you don't say C5H12, it's going to be C5H10, right? Okay, like that. Now we're going to do the nomenclature later. Again, we can label the atoms and show that here is a methyl group attached to it. If there's only one substituent on the cycloalkane, we don't say anything, because there's going to be only one position, right? You don't have to say 1 methane. But if you have 2, it could be 1,1-dimethyl pentane or 1,2-dimethyl, right? Then it also has a problem here. For example, if you have a methane, cyclopentane, and 2 methyl substituent, okay? Okay. Now I stick 2 methyl groups, right? Now this one, you cannot rotate like in rotate like in alkanes. Alkanes, you can rotate the molecule, right? For example, if you have these, so you can rotate, and there's no this side or that side, it's just the conformations. I'm going to talk about conformation, rotating on a single bond, create the conformations. But in this case, this is distinct when the 2 substituents are on one side, 2 methyl groups on the top, or the 2 methyl groups are on the bottom here, like this, here. This one is called trans, other one is called cis isomer. They're called geometrical isomers. Geometrical isomers, I'm going to talk about again, are created by rigidity of the structure, because you cannot rotate around the carbon-carbon double bonds there because of the ring. Or double bonds sometimes create a rigidity. You get cis and trans isomers, all right? Okay. All right, I think I got enough to get you to understand the problems. that are in the in here. Okay, IPAC name of the following substituted cycloalkane. Now, this is kind of a I'm not asking what is this. What is this? Cyclohexane. All right. Now, because there are the angles, this is the line angle formula of cycloalkane. There are 6 carbon atoms. It should be drawn a little bit better than this. Okay, like this. All right. So now this is the branch cyclohexane, right? Now, how do you name it? The parent name is cyclohexane. Now we have to identify this group and that group and the number here. Okay? Now that would be, if you get this one, I'll be really happy. What that group is? Third butyl. Remember, I was going to show you this butyl. This is CH3, CH2, CH2, CH2. That group is N-butyl, right? And this group is 1, 2, 3 isobutyl, and this group was called this is CH3, 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 CH, CH2. Okay, this is the way it is stuck here to the other. This is called third butyl. All right, this is the one right here. Remember we talked about it other class? Okay. So anyway, this is methyl. This is tertiary or third butyl. There are 4 carbon atoms here. Okay. Okay. How do you number now? How do you number this? Which one get the number 1? Most complex alkyl group. The more carbon atom it has, all right? In this case, this is going to be 1, 2, 3, 4, right? Methyl is kind of a simple case, right? All right, so we call it 4-methyl, and this is going to be 1. You have to say 1, otherwise we don't know where it is, right? So it's going to be, the IPAC name of the thing is going to be 4-methyl 1/3 butyl cyclohexane. All right? Yeah.
In the notes it says that we label them with the higher alphabetical priority first. I don't know if it's...
I went here M.
No.
Now this is going to be the case. Google it, okay? If you didn't see a name for that one, that means I'm going to talk about this again, all right? This is good learning experience. I will go and check it, okay? And if I made a big mistake, I will come back and tell you. That's where the Supreme Court can decide on these issues, you know.
I know, right?
We can write a case to that. Okay, common name is Here, methylene, chloride. You have to know common names. You cannot, there's no systematic name. This one is called chloroform. This one is called freon. It's on the book, 1-1. All right. This is called freon 1,2. There's a, I think in the book there's a focus material in there, you know, in a highlighted area. Okay, IPAC name is dichloromethane. Remember, haloalkanes, IPAC name is
Dichloro what?
methane. Methane. Only one carbon atom. Okay, that's going to be trichloro. All right, this one is going to be trichloro. All have how many carbon atoms? One. They're going to be all methane. Okay, freon is going to be fluoro, okay.
Is that all one word?
Yes. All one word. Page 351. One word. You're safe. Okay. All right. Number 7. After that, I'm going to give you a quiz. Define the following types of isomerism or terms used. Now, isomers are, I talked about it. Isomers are compounds with the same chemical formula or molecular formula, right? Compound with the same chemical formula, but different molecular structure, right? Molecular structure. Molecular structure could be different. So we're going to explain how the molecular structure is going to be different. Okay. Same chemical formula. Now this molecular structure is how the atoms are arranged in the real molecule, right? Okay. So therefore there are few types of isomerism. Isomerism is general term. You know, if we have different molecular structure, and it's going to be isomer of this molecule is different, have different structure from other one. Now constitutional isomers is have different connectivity. Now, for example, this one is C2H6O, for example. Now, there are going to be different formulas for this. For example, molecular structure. This is a constitutional isomer, again. I'm giving an example. O, this. These are two different compounds. These are constitutional items. Conductivity is completely different. Okay? But I can have other examples too for different types. Okay. So this same formula could have different things, the way they bonded. When they are bonding, you have to follow the rules. Oxygen will bond will make 2 bonds, covalent bonds. Carbon makes 4 covalent bonds, and hydrogen makes 1. Now, for example, butane. We already looked at it. This is CH2, CH3. Now the connectivity is different. This one has a secondary carbon atom. You see that? Different types of carbon atoms are there. Okay, but the connectivity is different. They're called constitution. Remember?
Is it the same thing? Or no? They're on the.
Okay. I got it here. It had okay. The earlier example was didn't have the same number of carbon atoms and hydrogens. Okay, therefore I violated my rules. Okay, this one is butane. This is going to be isobutane. Remember we talked about 2 different isomers. They have completely different properties, just like pentane has. Isopentane and neopentane, remember I talked about? Which one would have a higher boiling point? This one, right? Because the lower the branch, the higher the boiling point. Okay. Okay, I'm going to stop at this. Right now I'm going to do, I cannot finish that one. Okay, now the quiz.